All right, 2.4, day 2. Today we're going to focus on dividing complex numbers. Okay, that's basically one of the learning targets, dividing complex numbers. We're going to do that by using complex conjugates. And then we're also going to work on solving quadratics, which we've already reviewed this. However, they will have answers that are going to be complex numbers. They happen to always be complex conjugates of each other when that happens. Okay, so that's it. These two types of problems. I'm going to do one, then you try it, and then I'll do one, and then you try it. Okay, so here we go. All right, complex conjugate. This phrase refers to this relationship right here. If we have a complex number in the form a plus bi, a minus bi is called the complex conjugate. And it just so happens that there's a pattern whenever we multiply them together. And I'm going to show you right here. Go ahead and write this down. So if we multiply this together, we have first times first. So we get a squared. Outside two terms, we're going to get negative abi. Inside two terms, we get positive abi. And the last two terms, positive times negative is negative. And we're going to have b squared I squared. All right, so let's simplify this. These middle terms are opposites, so they're gone. So I'm left with a squared minus b squared times negative 1. Okay, and negative 1 times the negative becomes positive, so we end up with a squared plus b squared. All right, so notice the imaginary unit is gone. That's kind of the conclusion we want to draw from using these complex conjugates. Anytime I multiply a complex number by its conjugate, the imaginary unit is gone in the results. All right, so when we have a problem like 15, we're going to use that to our advantage. Divide complex numbers requires using complex conjugates. Let me show you. What I'm going to do is multiply this denominator by the complex conjugate of 2 plus 3i. So that's 2 minus 3i. Why am I choosing to do that? Because I'm using this to my advantage. I know when doing that, it will result in something that doesn't have an imaginary unit. Okay, we're not supposed to leave radicals in the denominator. Something they called rationalizing in geometry. We're kind of rationalizing this, getting rid of that radical square root of negative 1. Okay, now I can't just change the value of this problem. So what we want to do is also do the same thing on top. Because essentially now I'm just multiplying this by 1. And multiplying this by 1 doesn't change the value. Now it's going to change the look, but not the value. I can relate this to something like this. Like I said, back in geometry, you had 1 over the square root of 3, and your teacher told you to rationalize it. So we'd have to multiply it by square root of 3 over square root of 3, which is 1, but it would get rid of the radical. Okay, we're kind of doing a fancy form of that. All right, so now we just got to do the algebra. If you know how to start it, that's key, because the algebra, most of you guys have these skills down. Let's start at the bottom. So let's FOIL this. 2 times 2, put in parentheses if you feel more comfortable with that. So it gives me 4. Outside two terms, I get negative 6i. Inside two terms, I get positive 6i. And then the last two terms, I get negative 9i squared. Let's keep going with the bottom, then we'll focus on the numerator. So the i's are gone. I have 4 now minus 9 times negative 1, which is going to give me 4 plus 9, which is 13. So that's what I was talking about. By choosing to multiply by the conjugate, you should have just some type of integer or real number as a result. You're not going to have an imaginary number anymore. Okay, now up in the numerator. This one isn't a binomial, just a monomial times a binomial. So we'll just distribute now. So 4i times 2 gives me 8i. And then 4i times 3i gives me minus 12i squared. So this is 8i, remember, this is just negative 1, right? So negative 1 times the negative 12 is positive 12. So it's 12 plus 8i, okay? Which I still have here. All right, your final step, though, usually the directions will say to put in standard form. I probably need to redo these directions, but we'll just put it right here. Put in standard form is what the directions will say in your quiz. And by standard form, in these types of problems, they mean A plus BI. All right, so what I want you to do is kind of break it apart. Realize that this is being divided by 13 and the 12 is being divided by 13. They both are. So we're going to say 12 over 13 plus 8/13 I. And now you can clearly see that it's in that form, A plus BI. If I could reduce the fraction, this would be the time where I'd want to do that. But 13 is a prime number, so I can't reduce it. That's the answer. All right. Okay. Pause it now and go ahead and try 16. Okay, here's your feedback. 4 plus 5i is what we need to multiply it by to get rid of that imaginary unit. Okay, got to do the same on top. So here's the next step. Foil the top and bottom. Careful on all these little steps. A little mistake on your sign somewhere is going to throw everything off. So here's on the bottom. I have 16 now plus 25, so I end up with 41 on the bottom. Up top, 3 plus 14i. Now break it apart and put it in standard form and reduce if possible. In this case, I can't reduce any of those. There it is. Okay, last part, solving these quadratics using the quad formula. Solve each quad equation using the quad formula. Express solutions in standard form. So that's going to be the A plus BI form again. Okay, so here we go. All right, already is in standard form. So if like the 2 was on the other side, move it over so I can get A, B, and C. All right, but we're ready to set this in. So X is going to be equal to the opposite of B. So that's positive 2 plus or minus B squared minus 4AC. Always put your B in parentheses in case you're going to your calculator like that. You're going to need it. So negative 2 squared minus 4 times A times C. All over 2 times 1. First step is always the messiest. It looks the messiest. After one step, if you do as I'm demonstrating, it'll be cleaned up pretty quickly. I've always told you just plug in the discriminant, what's under the radical, that is, as you see it on paper. B squared minus 4 times the A times the C. Okay? So we end up with negative 4, just like that. So B plus or minus the square roots of negative 4 all over 2 times A. Another thing I should clean up on this step and write 2. Now it looks a lot more reasonable. Okay. So square root negative 4. We worked on simplifying stuff like that on Friday. Square root negative 25, right, was 5i. Now this is negative 4. We should say 2i. So this is equal to 2 plus or minus 2i over the square root of 2. All right, and then just use that skill I just worked on 15 and 16. I said break it apart. Realize that both of these are being divided by 2 in this case, and break it apart and reduce. So that's divided by 2. This is divided by 2. So 2 plus or minus 2i over 2. Oops, I forgot to put that over 2. There we go, 2 over 2. So we end up with 1 plus or minus 1i. Okay. Which means there's really 2 solutions. There's another way we could write this. We could write this as x equals 1 plus I and 1 minus I. It's actually something that's always going to happen with a quadratic that has a negative under the radical. They will be conjugates of each other. But you can write like this, right? Easier way to do it. Okay, your turn. You try 18. Pause and give it a shot. All right, so here's our setup for 18. 4 minus this in my calculator gives me negative 44. All right, another thing, a skill we practiced again on the previous day. How do I simplify that? 4 can come out as 2, and the negative 1 come out as I. So 2I comes out, and the 11 stays under the radical, like this. 2I square root of 11. Okay, and then we're going to break it up and reduce it. So I've got 2 6 plus 2I square root of 11 over 6, and then both of these are going to produce a 1/3 relationship. So I have 1/3 plus or minus I square root of 11, 3. Now, another way you could write this, as I mentioned before, sometimes in the back they'll put the I last, because here's the B term is technically square root of 11 over 3, and then they might write I right there. That's okay. Just know that they're the same, because multiple choice, I'm not sure which way it will be expressed. Both are fine. Okay, a couple things I want to get ahead of from the assignment, just to make sure that you're not confused on. One of your problems that you're going to be doing is 51. 47, 49 look a lot like the book, and then this one has a little different denominator. Okay, so what do you do if it's just I? Well, same idea, complex conjugate of the denominator. So for a problem like 51, well, this in standard form is 0 plus I right now, right? So what do you think its conjugate would be? 0 minus I. Okay, or we don't really have to do the 0 minus I. We could just say negative I. Okay, so that's what you do on a situation like this. Its conjugate is negative I, and it actually works, the algebra is a little bit easier when you work through it. Okay, so that's my advice for 51. 66 is also kind of a tougher one, which I want to talk about too. Remember, kind of covered this today as well when we went through the OTI feedback. You can't multiply, this is how the problem starts. You can't multiply these together unless it's positive under the radical. So before I start multiplying this, I have to take care of that and do I squared of 6. I squared of 6. Okay, and now I can start foiling this. I'm just going to show you one more step and then let you finish it. I don't think first, outside and inside would be that big of a deal, but the last one, when I multiply these together, it's negative times negative, so it's positive. I get I squared, and then the square root of 6 times square root of 6 can be multiplied together now that it's positive. So I'll say square root of 36 or just 6. Okay, so that's negative 1 and 6, I end up with negative 6. So that's how I get around that. Okay, all right, that's it here for 2.4.